Welcome back to your next lesson in organic chemistry. Today we are going to focus on alkenes. Now let's just quickly recap. First of all, we had a look at the different prefixes, and if we can quickly scan through them, we had meth, eth, prop, but, pent, 6 is hex, 7 ept, oct, non, and dic. And then we started to have a look at the different homologous series. First of all, there was alkanes. We said that alkanes consist of single carbon bonds only, and that the compound will always end with the word "ane". All right. Today we are looking at alkenes. So, an alkene has a functional group that looks like this. As you can see, it has a double bond. So an alkene is a homologous series with a functional group that looks like this, and it has a double bond between two carbons. Another thing, let's quickly count the amount of bonds around each carbon. 1, 2, 3, 4 for the first one. Can you see there can be a maximum amount of 4 bonds around each carbon? Looking at the next one, 1, 2, 3, 4 again. So each carbon only has 4 bonds around it. Right. Because this compound already has a double bond in between, therefore we can only add another 2 bonds in the form of hydrogens. So this specific carbon compound, which is an alkene, will look like this. There will only be an additional 2 hydrogens around each carbon because of the double bond that already takes up 2 of the vacant spaces around each carbon. Let's go and name this one. First of all, we have to circle our longest carbon chain. It has 2 carbons. Therefore, it will start off with a prefix of eth. Alright, and because it is a double bond, it is an alkene, it will end with ene. Now, this little guy is called ethene. It also has a common name, which is ethylene. All right, let's do another one. Okay, so we have the following carbon structure. And again, I won't be writing the hydrogens each time, but please remember, do write it in your exercise book and specifically in all exam and test papers. Always remember to write down your hydrogens. Let's just go and check if we did write the right amount of hydrogens around each carbon, because there can be a maximum of 4 bonds around each carbon. Going on to the first one, it has 1, 2, 3, 4 bonds. Yes. Let's go to the second carbon. It has 1, 2, 3, 4 bonds. Yes. Next one, 1, 2, 3, 4 bonds around this carbon as well. Okay, so the amount of hydrogens drawn around each carbon is correct because we can have a maximum of 4 bonds around each carbon. So let's start off circling our longest carbon chain. All right, now something new is coming up. Because there's a double bond in this carbon chain, we have to number these carbons. Now guys, we start to number on the side where the most is happening, and that includes mainly your double or triple bonds. So on the left hand side of this compound, we have a double bond. Therefore, we will start numbering this carbon chain from left to right, because the double bond is the closest to the left hand side. Carbon 1, carbon 2, carbon 3. Okay, this compound has 3 bonds in it, therefore it will be prop. And it has a double bond in it, therefore it will be ene. But now the question is, exactly where does this double bond find itself? This double bond is connected to carbon 1 as well as to carbon 2. But we indicate for naming purposes the lowest number carbon it is connected to. So we have prop because it's 3 carbons, and then the double bond is connected to the lowest carbon being 1. We don't mention the 2, we mention the lowest number. So it is prop dash 1 dash and then ene because it is a double bond. There you go, not too bad, eh? Please remember that in organic, between a number and a word, we have a dash. Later on, we will have more than 2 numbers, then we have a comma. Let's look at another example. Okay, I'm not going to be drawing the hydrogens in this one, just saving some time. But remember that there can be a maximum of 4 hydrogens around each carbon, a maximum of 4 bonds around each carbon. And it doesn't really matter whether you put your hydrogen at the top or the bottom. It is just a matter of which side you're standing of the carbon. But there still can be a maximum of 4 bonds around each carbon. Okay, circling the longest carbon chain, there you go. But because there is a double bond in it, we need to number it. We're going to number on the side where the most is happening first of all. Now if you look closely, this double bond is exactly in the middle. So it doesn't really matter whether we start numbering from left to right or right to left. I just like numbering left to right. So I'll be starting with 1 there, 2 there, 3, 4, 5, 6. We have 6 carbons in this chain, so it will be hex. Right? And because the smallest number to which the double bond is attached to is 3, we will therefore write dash 3 dash, and it is a double bond, so it will end with ene. Hex 3n. A last one. Okay, again, I'm going to skip the hydrogens, but please remember to draw your bonds as well as your hydrogens in your exercise as well as your exam book, guys. If you don't do it while you're practicing, you just might lose unnecessarily marks because you don't write it in your test. Okay, let's circle the longest carbon chain. Because there's a double bond, I'm going to have to number these carbons. The double bond is on the left, so I'm going to number from left to right. The double bond is connected to the smallest carbon being 1. We have 4 carbons, which means but, then dash 1, and because it is a double bond, we end off with ene. There you go. It really isn't that bad. I'm going to give you a few to practice on your own, and please feel free to send me your answers or to message me if you need help with attempting these questions. There comes your first one. And then for the last one, I'm going to give you the name. And I would like you to please try and draw it. Pent to ene. That's it for this lesson, guys. See you in the next. And remember, keep practicing.